Students, then continuing the slope deflection method, analysis of frames without sway. Analysis of frames. Portal frames are often used in buildings and are composed of beams and columns connected with fixed joint. In general, portal frames are of two types. One is symmetrical portal frames, that means the portal frames without sway, and unsymmetrical portal frames, that means the portal frames with sway. Symmetrical frames are that in which both columns are of the same length, having similar end conditions, having moment of inertia, modulus of elasticity, as well as subjected to symmetrical loading. That means that symmetrical portal frames, that means there will not be any sway. If there is any lateral movement is permitted, that means sway is there. In this lecture, we are dealing with the analysis of frames without sway. Analyze the frame shown in figure, and this is the frame given. The analysis of frames without sway by using the slope deflection method, that is similar to the analysis of beams by using slope deflection method. As in the case of analysis of beams, the step 1 is fixed and moments here also. Then for AB, it is subjected to an eccentric point load. That means M bar AB is minus W AB square by L square, and M bar BA is W A square B by L square. Since there is no load in BC, that means the fixed end moment, that means M bar BC and M bar CB is 0. Then second step is slope deflection equation. We know MAB is equal to M bar AB plus 2EI by L into 2IA plus IB minus 3 delta by L. Since it is without sway, that means delta is equal to 0. And since A is a fixed support, that means IA is equal to 0. And we are having two unknowns here, one is IB and one is IC. Then in the case of slope deflection equation, substitute all the fixed end moments, and IA is equal to 0 and delta value is equal to 0. Then we will get the equation number 1, 2, 3 and 4. After writing the slope deflection equation, the step 3 is joint equilibrium equation. In the case of joint equilibrium equation, we are having two unknowns. One is IB and one is IC. Then not to find out these two unknowns, we should have two equations. What are the two joint equilibrium equations here to find out the unknowns? One is MCB is equal to 0 since the joint C is a simply supported one. And MBA plus MBC is equal to 0. From step 2, we know the equation of MCB. Substitute that is equal to 0, then we will get one equation, that is equation number A. And the second one is MBA plus MBC is equal to 0. We know the equations for MBA as well as MBC, and substitute that equations here, then we will get the second equation. Then solve these two equations, then we will get EIIB and EIIC. After getting EIIB and EIIC, substitute this in step number 2. Substitute this in the slope deflection equations, then we will get the final moments. After getting final moments, draw the bending moment diagram. Okay, then draw the bending moment diagram. Then firstly, draw the free bending moment diagram. The AB is subjected to a point load, that means that is a triangle with the value W AB by L, and BC is not subjected to any type of load, that means there is no free bending moment diagram. Then in the case of AB, the value of MAB is minus 20.57, that means that is in the anti-clockwise direction. Mark minus 20.57 in the anti-clockwise direction from AB. The value of BA is 9.26, that means plus 9.26, that means that is in the clockwise direction. Then mark from BA in the clockwise direction 9.26. Then MBC is minus 9.26. Then mark from BC in anti-clockwise direction minus 9.26 and MCB is equal to 0. Join all these values, then we will get the combined bending moment diagram. In order to draw the shear force diagram, find out all the support reactions by considering the reactions, external load and the support moments obtained in the step number 4. Then applying the equilibrium equations, then we will get the value of RA, RB1, RB2 and RC. RA is in the upward direction. Then this load is in the 30 is in the downward direction. Then here also RB1 is in the upward direction. RB2 is in towards left. Then RC we got the value as negative minus 3.7. That means minus 3.7 means your assumed direction is wrong. Your assumed direction is towards right. You got the value of minus 3.7. That means the direction should be towards left. So mark RC towards left, join these two. This is the shear force diagram. Then considering the next problem, analyze the frame shown in figure using slope deflection method. Then step 1 is fixed end moments. This is an eccentric point load, that means M bar AB is minus WAB square by L square, then plus WA square B by L square minus WL square by 12 plus WL square by 12, then minus WAB square by L square plus WA square B by L square. Then write the slope deflection equation. Then consider this figure. Joint A is the fixed one, joint D is the fixed one, then IA is equal to 0, ID is equal to 0, IB and IC are there. Then there is no delta value. Then in the slope deflection equation, substitute all the fixed end moments. Delta is equal to 0, IA is equal to 0 and ID is equal to 0. Then we will get the equation number 1, 2, 3, 4, 5 and 6. After getting the slope deflection equation, write the joint equilibrium equation. We are having two unknowns IB and IC. That means we should get two equations, joint equilibrium equations. What are these two joint equilibrium equations? One is MBA plus MBC is equal to 0 and MCB plus MCD is equal to 0. We know the equation of MBA and MBC. Substitute the equation, then you will get the equation number A. MCB plus MCD is equal to 0. Then we will get the equation of B. By solving A and B, we will get EAIB and EAIC. Substituting the value of EAIB and EAIC in the slope deflection equation given in step number 2, then we will get the final moments. After getting the final moments, we can draw the bending moment diagram, and after getting the support reaction, we can draw the shear force diagram. Then we can see one more problem. Analyze the loaded frame. Then M bar, the first step is fixed end moments. M bar AB means W minus WAB square by L square. M bar BA means WA square B by L square. M bar BC means the minus WL square by 12 and M bar CB is plus WL square by 12. Then in the case of BD, there is no load, that means there is no fixed end moment. After getting the fixed end moment, then write the slope deflection equation. Then from the figure we can find out IA. Then from the figure we can find out A is the simply supported one. A simply supported one means there is a value of IA, and D is fixed one. D fixed one means ID is equal to 0. C is also a fixed one, that means IC is equal to 0. Then IA is there, IB is there, IC 0, ID 0. Then you can write the slope deflection equation. Substitute all the fixed end moments here. Then delta value is equal to 0. Then IC is equal to 0 and ID is equal to 0. Then we will get the equation 1, 2, 3, 4, 5, 6. After getting these equations, then you know you are having two unknowns. What are the two unknowns? IA and IB. In order to find out these two unknowns, we should find out two equations. What are the two joint equilibrium equation? One is, since A is a simply supported one, that means MAB is equal to 0. Since joint B means BA plus MBA plus MBC plus MBD is equal to 0. Now to keep the joint B in equilibrium, we should consider MBA plus MBC plus MBD is equal to 0. We know the equation of AB, MAB. That means substitute the equation of MAB is equal to 0. Then we will get one equation. Then second equation is MBA plus MBC plus MBD is equal to 0. Then we will get the second equation. By solving these two equations, we will get the value of EAIA and EAIB. Substituting these values of EAIA and EAIB in slope deflection equation, then we will get the final moments. Then as in the previous cases, after getting the final moments, we can draw the bending moment diagram. And after getting the support reactions, we can draw the shear force diagram. Then one more case is there in the case of analysis of frame, that is overhang. Then analyze the frame using the slope deflection method. By using this diagram, firstly write the fixed end moments M bar AB, M bar BA, then M bar BC and M bar CB. AB is subjected to UDL, that means M bar AB is minus WL square by 12 and M bar BA is plus WL square by 12. Then BC is subjected to central point load, that means M bar BC is minus WL by 8 and M bar CB is plus WL by 8. Then after getting the fixed end moments, please write the step 2, that is slope deflection equation. The slope deflection equation, we can substitute all the fixed end moments and the delta value is 0. And since A is the fixed support, that means IA is equal to 0. And C is also a fixed support, that means IC is equal to 0. That means we are having only one unknown. That one unknown is IB. In order to get this value of IB, we should find out one joint equilibrium equation. Which is that one joint equilibrium equation? That is step number 3. What is the joint equilibrium equation here? MBA plus MBC plus MBD is equal to 0. In order to keep that joint B in equilibrium, our joint equilibrium condition is MBA plus MBC plus MBD is equal to 0. Okay, then in this case, MBD means MBD, that means moment at B for the span BD. We know the overhanging moment is 10 into 1.5, that is 15 kilonewton meter in the clockwise direction. In order to resist that 15 kilonewton meter clockwise moment, the support B for the span BD, that means MBD, should be minus 15 kilonewton meter, that is in the anti-clockwise direction. In order to resist the clockwise 15 kilonewton meter, the support has to give anti-clockwise 15 kilonewton meter for the resistance, for the equilibrium. Therefore, the value of MBD is minus 15 kilonewton meter. In the equation, MBA plus MBC plus MBD is equal to 0. In this, MBD is minus 15. That means we can write the joint equilibrium equation as MBA plus MBC is equal to 15. We know the equation of MBA and we know the equation of MBC. Substitute these equations, then we can find out the unknown EIIB. After getting the unknown EIIB, substitute this value in the step number 2, that means in the slope deflection equation, then we will get the final moments like this. After getting the final moments, we can draw the minimum moment diagram. Thank you.